Have you ever wondered how life originated on Earth? We start our journey some 4.5 billion years ago when our planet was but a newborn, a fiery infant in the grand cosmic nursery. Back then, Earth was unrecognizable compared to the blue marble we know today. It was a hot molten mass, a roiling sphere of magma and rock spinning in the void of space. This primordial Earth was not a hospitable place. It was tumultuous, chaotic, and exceedingly hot, a far cry from the life-sustaining world we inhabit today. Yet it was this hostile environment that set the stage for the greatest show in the universe, the birth of life. As the eons rolled by, Earth began to cool down. The molten surface solidified, forming the first crust, a thin, hard shell encasing the fiery heart of the planet. This was the first step in Earth's transformation, the first step in creating a world capable of sustaining life. But the Earth was still an inhospitable place. There was no breathable air, no blue skies, no soft rains. The atmosphere was a toxic cocktail of gases, including methane, ammonia, and water vapor, released by volcanic eruptions. Yet over millions of years these gases began to change. Water vapor condensed and fell as rain, over and over for thousands of years, filling the basins and lowlands, creating the first oceans. These oceans acted as a colossal carbon sink, absorbing carbon dioxide from the atmosphere, making the air more breathable, more life-friendly. And so, the Earth continued to transform. It cooled, it rained, oceans formed, and the atmosphere changed. Over billions of years, the Earth evolved from a hot, molten mass into a world with a solid crust, an atmosphere, and vast oceans. A world that was ready to cradle life. In this inhospitable environment, the stage was set for the miracle of life to begin. But where did the first building blocks of life come from? Let's travel back in time, over 3.5 billion years ago, to when Earth's oceans were a swirling mixture of elements. This was no ordinary ocean, but one that teemed with a concoction of chemicals. The term primordial soup was coined to describe this early ocean, a broth rich in organic compounds, the raw materials necessary for life to emerge. So how did these organic compounds form? Enter the Miller-Urey experiment. In the mid-20th century, scientists Stanley Miller and Harold Urey sought to recreate the conditions of Earth's early atmosphere in a laboratory setting. They filled a closed system with gases thought to be present in the early Earth's atmosphere, such as methane, ammonia, and hydrogen. They then applied an electrical discharge, simulating lightning. What they discovered was nothing short of groundbreaking. After just 1 week, they found that their experimental setup had produced amino acids. These are the building blocks of proteins, which in turn are the building blocks of life. This experiment showed that the conditions on early Earth could indeed have led to the formation of life's essential components. But the story doesn't end there. The formation of amino acids is just the first step. These amino acids had to link together to form proteins, a process that likely occurred in the warm, mineral-rich waters of the primordial soup. These proteins then had to find a way to replicate, a key characteristic of life. The primordial soup theory, while not without its critics, provides a plausible explanation of how life could have originated on Earth. It suggests that life emerged not from some miraculous event, but from the natural processes of chemistry and physics, given the right conditions and enough time. From these simple organic compounds, the complexity of life began to take shape. So how did these organic compounds evolve into living organisms? To understand this, we must delve into the concept of abiogenesis, a theory that proposes life arose naturally from non-living organic compounds. Picture a world teeming with these compounds, gradually moving and reacting with each other over countless eons. Through countless interactions, driven by the energy from the sun and the Earth's geothermal heat, these compounds eventually formed more complex structures, such as proteins and nucleic acids. These complex structures were the precursors to what we now know as cells, the building blocks of life. But don't imagine these early cells as anything like the intricate cells we know today. These were likely simple prokaryotes, primitive cells without a nucleus or other complex structures. They were just tiny encapsulated droplets, structures that could maintain a stable internal environment separate from their surroundings. Now, if you're wondering how these simple cells became capable of life, then we need to introduce another significant player in this tale: DNA. The evolution of DNA was a game changer in the story of life. It provided a way for these cells to store information, to pass on traits, and to evolve over time. Imagine a world where these simple cells are replicating, making copies of themselves. But each replication isn't perfect. There are tiny changes or mutations. Most of these changes might be harmful, causing the cell to die. But once in a while a mutation might be beneficial, giving the cell an advantage in survival or reproduction. Over time, these beneficial mutations accumulate, leading to cells that are more complex and better adapted to their environment. This process, known as natural selection, is the engine of evolution. It's a slow process, taking billions of years, but it led to the incredible diversity of life we see today. From these humble beginnings, life on Earth evolved into an array of forms, from the simplest bacteria to the most complex organisms. These simple cells were the ancestors of all life on Earth. But how did we get from simple cells to the diversity of life we see today? Well, the answer lies in the remarkable process of evolution by natural selection, first proposed by Charles Darwin. This process has been shaping life on Earth for billions of years. Imagine the early oceans teeming with simple, single-celled organisms. Over time, these organisms evolve, becoming more complex. They develop features like flagella for movement, chloroplasts for photosynthesis, and even simple nervous systems. This process is not random, but guided by the pressures of the environment. Those organisms that are better adapted to their environment have a better chance of surviving and reproducing, passing on their advantageous traits to the next generation. Over hundreds of millions of years, the oceans become a cradle of biodiversity. Eventually, some life forms venture onto land, a monumental step in the history of life. These pioneering organisms face new challenges: gravity, temperature fluctuations, and the need to find or create moisture. Yet, they adapt and thrive, leading to the colonization of every corner of our planet. From the highest mountains to the deepest caves, life finds a way. As life continues its relentless march, complex multicellular organisms emerge. Plants, insects, fish, reptiles, mammals, the Earth is transformed into a vibrant, bustling world of diverse life forms. Yet it's not a smooth journey. Major extinction events punctuate the history of life, each one reshaping the course of evolution. These events might seem catastrophic, but they also open up new ecological niches, allowing for the emergence of new species and the further diversification of life. Through these cycles of evolution and extinction, life on Earth has evolved from simple single-celled organisms to the vast array of species we see today. From the microscopic bacteria that inhabit our gut to the majestic blue whales that roam the oceans, to us, humans, with our unique ability to ponder our own existence. Through billions of years of evolution, life on Earth has become the complex, diverse phenomenon we see today. So, how did life originate on Earth? Our journey began with the formation of Earth, a cosmic event that set the stage for the miracle of life. Born out of the dust and gas of a young solar system, Earth transformed over billions of years, from a molten mass of rock to a planet with an atmosphere and oceans. With this transformation, the stage was set for the next act, the creation of the Primordial Soup. This wasn't a soup you'd want to eat, but rather a mixture of water, methane, ammonia, and hydrogen. These simple ingredients, catalyzed by the energy from the sun and Earth's own inner heat, formed the complex organic compounds that are the building blocks of life. Amino acids, nucleotides, and simple sugars all began to assemble in these ancient oceans. From this primordial soup, the first cells arose. These weren't cells as we know them today, but rather simple structures encapsulating self-replicating molecules. Over time, these early cells underwent countless cycles of division and mutation, slowly evolving into more complex forms, and thus, the evolution of life began. Starting with these primitive cells, life diversified and adapted to fill every niche on our planet. Through the process of natural selection, life forms became more complex, more specialized, and more diverse. From the depths of the ocean to the highest mountain peaks, from the coldest Arctic tundra to the hottest desert sands, life found a way to survive and thrive. The story of life's origin on Earth is a testament to the power of nature and the resilience of life. From the harshest of beginnings, life has flourished and diversified into the myriad forms we see today. And who knows what the future holds for life on our planet? It's a story of adaptation and perseverance. A story that continues to unfold as we delve deeper into our understanding of life's origins and look forward to its future.